The Dean of the College of Science, the Chairman and Head of the Department of Geology, and the General Secretary of the conference for allowing me to speak with you today. We at AKH Gold are very happy to sponsor this important conference on the geology of Africa, and we are also very happy to support Asiyut University and its geoscience department. I wanted to discuss with you really something that is specific to the universities that are here in attendance today, and in particular their geoscience departments. We're all familiar with the history of minerals in Egypt as very ancient, and it goes back whether it's precious metals, base metals, industrial metals. We're also very aware that in the early part of the 20th century, through economic depression, wars, that the industry slowed down. And so, for example, if we take gold mining, we know that there's only been one gold mine built in the last 100 years, and this, of course, was Sukari. We also realized that in the late 50s, early 60s, with the explosion in the oil and gas industry through large discoveries, that the mineral industry basically came to a bit of a halt. And the universities and the geology departments, as they were then, were asked to undertake to help do the academic research at work to help understand better the hydrocarbon systems that were here, especially in an environment where there were some of them very complex, especially in places like the Gulf of Suez. And so the universities came along to do this, but they were also tasked with training an army of geoscientists that were going to be required to do this. And the universities met that challenge. They did a lot of very solid academic work that led to our understanding of the oil, which helped with the development of the oil and gas business, but also turned out very fine geologists and geophysicists. And today, Egyptian petroleum geologists, geophysicists, very well respected, very sought after across the world. But the mineral industry sort of lost momentum. And the requirement was that, everybody focused on oil and gas. Well, the oil and gas industry now has become more mature. And we don't require as many of the geoscientists as we did before. But the mineral industry has a huge requirement. And to build the Egyptian mineral resources industry will require many geologists, geophysicists, to undertake the work that is required for the exploration. The one issue is, for the universities, and I think there are three parts to where the universities have a role to play. The first being is doing more work to understand the overall geology of Egypt and to understand that as it reflects on hard rock geology as opposed to sedimentology. And this is because we've lost a bit of time over this. There were very few people that were working on this. And so we need to do more. And if we look at an example, one of the things that never really ever was done was, say, an event sequence. So how was hard rock mineralization formed? How did it develop? If we take a look at Aton Resources' Abu Merawat concession, it's within 400 square kilometers. But within that 400 square kilometers, there's at least 4, possibly 5, distinct types of geology. And what we really didn't understand was, how did these form? How did they come together? And you know, one of the things that we learned over the years is that the geology of Egypt, when it comes to hard rock mineralization, is far more complex than would have you believe. Because a lot of what we know of hard rock geology went back 90 years, and times have changed, technologies have changed, exploration has changed. So doing this work to help understand the overall geology is crucial, not just for the country, but for the industry and its development over time. And leading on from that is a second area, which I think is very important. And that is that in this period of the early 60s, late 50s, early 60s, the Geological Survey of Egypt, which was the second oldest and is the second oldest in the world, sort of lost momentum. And it became somewhat neglected and underfunded. And petroleum was the byword, and minerals were sort of an afterthought. And over time, there wasn't a lot happening, and therefore there wasn't a lot of support. And it then morphed into eczema, and then it became ultimately what it is today, which is emerald. And the important part about this is that through no fault of their own, there was nowhere to go. There was no work really done. Eczema did some good work, but as time went by, there was no industry. And so what were they going to do? And that led to the problem that there wasn't really any experience. Then, of course, you had, hiring freezes and lack of bringing on young people, or the ability to bring on young people. And so there is a role today, while, the Geological Survey gets sorted out again, is to, for the universities to, in some ways, fulfill part of that job. Identifying minerals, not just the ones, and understanding better, not just the ones we know of in precious metals like gold and silver, or base metals like copper and zinc, or industrial minerals like phosphate, but also in terms of those minerals that we need to know whether we have, those that we haven't found already, those which are considered green minerals. And those green minerals like nickel, cobalt, copper, these are the future of the mineral industry in Egypt. And this is an industry that has huge potential. The geological potential of Egypt is probably not well understood, but it is huge. And the advantage of Egypt that most places don't have is because of this lack of exploration for so many years. It is actually a frontier province, but it has all the infrastructure that you could ever hope to have. So it's an amazing combination. But we need to understand more what we're doing. We need to attract more companies to come to Egypt to explore. Having 4 or 5 companies is great, but what you want are 400 or 500 companies here spending money, looking for different minerals. If we just take gold for a second, which is the main focus, there are several companies in the last 2 bid rounds, including ourselves, who are exploring for gold. But on an average, out of 10 to 15 companies that will be working here, only 1 will come up with a project. And that's why gold is so expensive, obviously, because it's very difficult to find in commercial quantities. You can find gold all over the place, but enough to create a mine, because that process of exploration, which leads on to the process of development, which finally will lead on to the process of mining, will take anywhere between 10 to 15 years on average across the world. Sukari itself took 14 years. Bisha in Eritrea took 15 years. And Jebel Sayed, well, that took 50 years. So, it's a long time frame, and it's not like oil and gas, where that turnaround time is pretty quick. And this is one of the problems. We have to realize that this is an oil and gas environment. People tend to think in oil and gas terms, but they're different businesses. And they're both extractive, but that's where the similarity ends. It's like trying to take Uber and its economics and compare it with British Airways and its economics. They may both be in transportation, but they're two completely different businesses. And the same is true for mining and oil and gas. So, trying to generate data, which we lack, to try and generate data, try and give an understanding to the industry as well that will make it attractive for people to come here, is an area that the universities can help to fill. And they're perfectly qualified to fill as well. And lastly, and the most important, is of course the training of the future. Today I was very happy to come and very happy to sponsor. The first time I came to the geoscience department at Assyut was 26 years ago with Sammy Araki at the Sentiment. And Sammy's view, having been a young man at the time that this whole change in minerals in the early 60s, realized that he was going to have to go somewhere else. And he was lucky enough to be able to immigrate to Australia, learn to be an exploration geologist, and in the end it came full circle because he came back again. Realized that it was our job as the industry to work with universities, support universities to be able to produce the future in exploration geologists, and I would also add the policy makers. That we then looked after, trying to bring in some way support to the university itself, but also to make sure that we were there to give jobs to train people. Geology is a practical science, and we learn in the university the basic science of geology, but you learn to be an exploration geologist by working in the field. And so it's important for the industry to take these young graduates and train them. And I'm very happy to say that the industry today is very good about this. And we do take fresh graduates, and we are training them in how to be exploration geologists. And we need to do more of this. But also, too, we need to work with the universities on a collaborative basis in terms of doing the work on geology here, understanding different deposits, understanding what minerals we have here, and to look for minerals that we may have here. So if we take nickel, for example, we know that we have found nickel, not in large quantities, but not much work has been done on it. But in those ultramafic complexes, we may have nickel in commercial quantities. But also, too, that could lead to us finding that we may have platinum group metals You know, the green minerals. Do we have lithium? Possibly. Nobody's looked for it, but it's something we should be looking for. You know, cobalt, another. We've seen rare earths associated with titanium mineral sands, the black sands. And so we are finding things, and we need to do more of that. We also could support universities by offering workshops and seminars, offering summer internships to students to come and see if being an exploration geologist is for them, and to work and understand what it is we do, and also to use the laboratory facilities. You know, many of you have very good petrology labs, geochemistry labs, certainly Assiout does. So instead of sending our samples out of the country, we can do our thin sections at a university petrology lab, our geochemical samples, have them tested in a university lab, and this is good not only for the industry, but it's also very good for the university. So there is a lot of collaboration that can be done, but there is no doubt that the key to success in the mineral industry in Egypt will be directly attributable to the universities and their geoscience programs. And as minerals become more important to the economy of Egypt, and you know, hydrocarbons, you know, less so, it's going to be the universities that help us develop the people of the future, you know, and to be able to develop not just the geologists, but the policymakers. And by that I mean, you know, subjects that we really need to look at teaching are economic geology, so that geologists understand the importance of identifying economic deposits and looking at how we would develop them, and mineral economics, so that the future policy makers understand the economics of managing the mineral resources of the country. Because ultimately the science is important, but it's a business. And it's a business from, you know, all the way from the policy makers, the Geological Survey of Egypt, to the actual operation of a mine, or just the exploration portion of that. So this is very important. And that's why I say, I think that, you know, if you look at the industry as a whole, we also require the help of the universities in understanding better the geology of Egypt. It's also key that, and